Hi, I hope you're doing great. Today, we will discuss a new topic regarding limits, specifically strategies to find limits. So, in the past video, I taught you what were limits and how to find them using direct substitution. Now, say you use this method, direct substitution, but the answer that it gives you is something like this, 0 over 0. Now, this is not a correct answer because it is indeterminate. So if you ever get stuck up with something like this, you must apply some strategies in order to get to the correct answer. And one of these strategies is factoring. So the first step ever when you have this type of problems is, say you have the limit of x squared plus x minus 6 over x plus 3 as x approaches negative 3. So as I said before, the first step is to apply direct substitution to see if you will get to an answer or you will get to an indeterminate form, like 0 over 0. So that will be negative 3 squared plus negative 3 minus 6 over negative 3 plus 3. Now that is equal to 0 over 0. So your answer is not correct. You must apply some strategies. So factoring. Factoring consists on getting the factors out of the numerator in order to cancel it out with the denominator and avoid having a 0 in that denominator. So what you must do here is factor out your numerator like the trial and error form. Simply two numbers whose product is negative 6 and that when you add them up they give you positive 1, which is a coefficient in here. So those two numbers are 3 and negative 2. So let's write them. You could say that the limit as x approaches negative 3 of x plus 3 times x minus 2 over x plus 3. This is the exact same thing up here. However, you must notice something really important here. You can cancel out this x plus 3 and x plus 3 in the denominator and numerator. So let's cancel them out. And you will be simply left off with x minus 2. So then you simply have to apply the direct substitution method again, however, only applying it to x minus 2. So then the limit of x minus 2 as x approaches negative 3 is negative 3 minus 2, it's negative 5. So that will be the answer to this problem. Now, the rationalizing technique applies for whenever you have a radical. So say you have the limit of square root of x plus 1 minus 1 over x as x approaches 0. So as always, the first step is to try the direct substitution to see if you will end up having 0 over 0. So simply substitute every x for a 0, and that will be the square root of 0 plus 1 minus 1 over 0. And yes, that is 0 over 0. So then, what you must do now is multiply this by the conjugate. And the conjugate would simply be the numerator, but changing this negative sign to a positive sign. So, that will be the limit as x approaches 0 of the square root of x plus 1 minus 1 over x, multiplying that by the conjugate. So the conjugate, as I said before, would be the square root of x plus 1 minus, change that sign to a positive, so that'll be a positive 1, over the same thing, square root of x plus 1 plus 1. Now, when you multiply by the conjugate, what you're doing here is applying like the difference of squares. So when you multiply, the radical will be canceled out. But let me show you the whole process just so you can see what's going on. Right now, I won't copy the limit just so I can take up more space, but just keep up in mind that the limit will appear later. So then, that will simply be this times this one, that will be the square root of x plus 1 squared. And then this times positive 1, that will be plus square root of x plus 1. Then negative 1 times the same square would be negative square root of x plus 1. And then this negative 1 times this positive 1, that will be negative 1. And here, that will be over x times the square root. Let's put a parenthesis there to multiply everything that's inside in this parentheses. Square root of x plus 1 plus 1. Notice something here. In this case, this will cancel out with this because I have a positive here and a negative here. And this, the radical, will cancel as well. So you will end up having a x plus 1 minus 1 over x times the square root of x plus 1 plus 1. So, in this case, this positive 1 will cancel out with this negative 1, and you will end up having just an x on the top and an x in the denominator. So cancel out those x's as well, and at the end you will end up having this. The limit of 1 over square root of x plus 1 as x approaches 0. So then you can solve this, and that will be 1 over the square root of 0 plus 1 plus 1. So it'll be 1 over the square root of 1 is 1 plus 1, that's 2. So the limit of that problem will be 1 over 2. Now let's do the last technique. So this involves trigonometric functions. So these are like special properties, as you could say, so like that. So the limit of sine of x over x as x approaches 0 is 1. And the limit of 1 minus cosine of x over x as x approaches 0 as well is 0. So, just to keep up in mind something in here, the x's must be the same. So, if I have a 2x here, the denominator must also be a 2x. So, let's do one problem applying this. So say you have the limit of sine of 3x over x as x approaches 0. Now, as I said before, you must have the same number, the same, this thing that's been applied, the sine function, in the numerator and the denominator. But here I only have an x. So what you can do is multiply this by 1/3 and multiply it by 3 as well. So basically, you'll be simply multiplying by 1, which won't affect your answer. So this will be the limit as x approaches 0 of sine of 3x over 3x times 3. Notice I multiplied 3 times 3 over 3 I mean, and that would simply like cancel out to become 0, but I need it right now just to get to the right answer. So if I were to solve this, you know already that the sine of 3x over 3x is equal to 1. So your answer would simply be the limit of x approaches 0 of sine 3x over 3x is 1 times 3. That will be 3, and that will be the answer to this limit.